You've definitely seen them. You're driving through the countryside, and there they are, just dotting the landscape, a constant rhythmic nod against the horizon. They are one of the most iconic symbols of the energy industry for sure. But have you ever stopped and wondered what's actually going on with each one of those slow dips and rises? Well, today we're explaining the nodding donkey. I mean, it's like a mechanical pulse in the landscape, isn't it? A slow, steady, rhythmic beat that's been part of the scenery for almost 100 years now. From the plains of Texas to oil fields all over the globe, you just can't mistake that motion. But, beyond that cool silhouette, what is this machine really doing? What problem does it solve with all that constant nodding? And how has it stayed so important for so long? Well, in this explainer, we are going to break it all down for you. We're going to look at the brilliant engineering behind it, trace its surprising history all the way from ancient wells to a workshop in Texas, and this is the cool part. We're going to explore how this 100-year-old design is getting supercharged with 21st century tech. So first things first, let's just get to know this machine a little better. I mean, its look is so distinctive, it's earned a whole bunch of really great descriptive nicknames over the years. People have called it the nodding donkey, the thirsty bird, the oil horse, even the grasshopper. Now, its official technical name is a sucker rod pump, but come on, names like rocking horse or big Texan just seem to capture its personality so much better, don't they? Okay, so nicknames aside, this machine is an absolute masterclass in simple, effective engineering. So how does it actually pull oil from thousands of feet below the ground? Well, it all comes down to this concept called artificial lift. See, when a new oil well is drilled, there's often enough natural pressure way down there to just push the oil right up to the surface. But over time, that pressure drops off. The well kind of needs a helping hand. The pump jack is that mechanical muscle, providing the lift to bring the oil the rest of the way. So let's look at the machine itself. On the surface, you've got the motor, or the prime mover, hooked up to a gearbox. That rotates the crank, and those huge counterweights, which in turn pushes that big walking beam up and down. At the front, you've got the horse head doing all the bobbing, pulling on a string of connected sucker rods that can stretch for miles down into the earth. But the real magic, the core of the whole system, is a brilliantly simple two-valve pump deep underground. Here's how it works. On the upstroke, a valve at the very bottom opens up, letting oil flow in. At the same time, a valve on the pump piston closes, so we can lift the whole column of oil above it. Then, on the downstroke, everything just reverses. The bottom valve closes, trapping that new oil, and the piston valve opens, letting the rods just slide down through the fluid. And that's it. It's this continuous cycle that just methodically walks the oil up, bit by bit, to the surface. But this elegant solution didn't just appear out of nowhere. The history of artificial lift is actually a really fascinating story of innovation over a long time. I mean, the basic idea goes back centuries. Early wells in China were using bamboo poles. Then, in 1859, the very first commercial oil well in the US used, believe it or not, a simple hand pump. By 1875, we saw a huge leap forward with something called the central power unit. This was a single steam engine that used a whole network of cables, they called them jerk lines, to operate dozens of pumps at once. But the real game changer? That came in 1925, thanks to an inventor named Walter C. Trout. Trout was working for Lufkin Industries down in Texas, and he designed the first self-contained counterbalanced unit. By adding those huge, heavy weights to the crank, his design perfectly balanced the immense load of all those sucker rods and the oil. This meant a much smaller, way more efficient motor could do all the work. That single innovation made it economical to put a dedicated pump on every single well, and it's the same fundamental design we still see everywhere today. Okay, so you might be wondering, in this age of crazy technological advancements, why is this almost 100-year-old design still the absolute backbone of onshore oil production? Well, the answer really comes down to economics. A single pump jack might only produce, say, 5 to 40 barrels of oil a day. These are often from what are called stripper wells, older, mature wells where production has slowed down to just a trickle. The pump jack is so reliable and so cheap to operate that it makes it profitable to keep these wells going, sometimes extending the life of an oil field for decades. Now, it's not the only way to do it. There are other methods, like electric submersible pumps, or ESPs, which are great for wells with higher volumes. But our trusty pump jack, the sucker rod pump, is still the most common form of artificial lift in the entire world. keeping a huge number of wells online that would otherwise be abandoned. And you can really see its importance when you look at North America, which just dominates the market. The region has a ton of these mature conventional oil basins. These aging fields depend heavily on pump jacks to maximize recovery and really to squeeze every last economic drop from wells that are already there. But, and this is important, don't mistake this old machine for a relic of the past. The pump jack is getting a massive, high-tech upgrade right now, transforming it from a simple mechanical device into a smart, data-driven asset. This quote really nails it. For decades, the philosophy was react and repair. If it breaks, you go fix it. But the whole mindset is shifting to predict and prevent, using data to see problems coming and fix them before they ever happen. Think about it this way. Instead of an operator having to drive out to a field to manually check a pump, smart systems can do that all remotely. And instead of just running at one constant speed day in and day out, the pump can now adapt in real time to what's happening deep down in the well. It's a complete change in philosophy, and it's all driven by data. And this is all possible because of a bunch of new technologies. You've got IoT sensors gathering constant data on things like vibration and temperature. You have variable frequency drives, or VFDs, which act like a smart dimmer switch for the motor, precisely adjusting its speed to save a ton of energy. And you have AI algorithms analyzing all this data to create digital twins, these virtual copies of the pump that can simulate and predict the health of the real machine out in the field. And believe me, this isn't some small trend. The amount of money being invested in oil and gas automation is massive. It's projected to be over $32 billion by 2030. This is all part of a huge push toward creating fully autonomous oil fields, where systems can basically optimize themselves with very little human help. So what you have here is a machine that was designed way back in 1925, now being hooked up to AI on the Internet of Things. It's this remarkable fusion of old-school mechanics and new-school tech. The simple, durable design of the nodding donkey is being made smarter and more efficient than its inventor could have ever dreamed, and that's ensuring its place on the horizon for many, many years to come.
Don't forget to like and subscribe for more How Meets History.